No, I am teaching.
Mom,
What?
anything divided by itself is one. Anything divided by one is itself.
I'm sorry, excuse me, what?
Anything divided by itself is itself. Anything divided by itself is one. Anything divided by one is itself.
That is correct. Okay, now go do your work. If you give me a few minutes, I can check you in
I
between
still
classes.
haven't
I'm so
done it.
sorry, y'all. I'm trying to shut the door, baby. Trying to do this and that all at the same time. Okay, let me turn on my camera. No, kitty cat. Cat decided to make his presence known. Okay, so y'all should be finishing, if not already finished, the opener. I want to know where you can find the S block, the P block, the D block. Oh, there's a typo, and the F block. I didn't put a comma there. And how many does each shell hold? So where do you find the S? How many does it hold? How many electrons? How many elements wide is it, essentially? Where is the P block? How many elements wide is that for its electrons? Where is the D block? How wide is that? And then where's the F block? How wide is that? Okay, I need to change this. We are not going to do element set 3 on Friday. We decided as a team to not do that. The 6 weeks exams, however, are this week. You guys are even, so that should be Thursday, if I'm remembering right. Which means that you guys will have a little bit of time to try to put your notebooks together on Wednesday. It's a shorter period. Y'all, your notebooks are due Thursday. Okay, now I put in Canvas, thanks for sneezing on my face, Kat. I put in Canvas, at least I should have, let me go back. Yes, the notebooks, notes lists in order. And if I did not link, and I don't think I did, but if I did not link how to digitally upload, I will do that. Yeah, second 6 weeks notebook submission. Okay, we're going to publish this one. Okay, so your notebook, I'm going to double check it when we get through with this. In fact, actually, let me click on it right now and double check it. Okay, it's hot, and I just made that active. It's something that you couldn't see just a second ago. What I did was I posted that I did in my Earth space from the first 6 weeks. So replace Earth space with chemistry and replace first 6 weeks with second 6 weeks. And you've got how to submit your notebook. Let's go back to the right slide. All right, so we are talking about electron configuration. Yes, I know that I didn't make notes 15 hot. I posted them and basically gave them to you. I did record, I did do a YouTube and recorded the notes that I did. And we will go back and double check the assignment that was from last week. It's still active. In fact, a lot of stuff I extended for a little bit. So if you did not do the quiz, once again, last Friday on set 2, the elements, the symbols and their names, that is opened again. I just opened it back up. So your notes, that's Earth space. It's notes 15. I may not have 16 open. I don't think I have 16 open right now. Let me open it. We are continuing on. We go into chemistry. Notes 17, 16. Here we go, 16. Sorry, I'm opening up yet another tab on my browser. So the first thing that you have, and I'm trying my best to underline what should be, I didn't do it. To underline what should be filled into the blank. Yeah, but electron configuration is, let me double check. How we show the structure, that's what should be underlined. Let me underline that right now. That's the one that you need to fill into the blank. So for the last couple days, well, skip the weekend, the last couple days, we've been talking about these shells, these orbitals, and there are 4 main sections on the periodic table, and I need to flip back to my screen. So this thing that we did, and if you guys have markers of your own, you should block out. What I did was I blocked out the S in red. Helium, which is over here, sort of belongs in this hole. But these first 2 rows, group 1A and 2A, if you put helium in this blank, this is your S block. They hold 2 electrons. Your P block is 6 elements wide, not helium, ignore helium. I blocked those out in purple, and I used marker. They hold 6 electrons. Your D block are your transition metals, and they're 10 wide, therefore they hold 10 electrons. And then your F block, D block I outlined in blue, and then F block I outlined in green. That these are your inner transition metals, and they're 14 elements wide, therefore they hold 14 electrons. That your periodic table does actually block this stuff out for you. It's just a matter of learning how to read your periodic table correctly. So your S shell holds, could be 1, but can't be more than 2. P can be 1 through 6, D can be 1 through 10, F can be 1 through 14. And they're literally blocked out on the periodic table where you've got, and I don't have my camera up, but you've got your S, your P, your D, and your F. They're literally blocked out. Oh, I can't wait to come back. This is not fun from home. Now we're going to do an example. We're going to do aluminum and then tin and then radium. And I'm hoping that I didn't mess up my my order of animation. But when you look at aluminum and you find it on the periodic table, its atomic number is 13. That means it has 13 electrons. And when we do this quant stuff, you're going to be filling in the electrons into holes. And I mean, if y'all just want to do like, can you do up caret and down caret? I don't think there's a down caret for you guys. And I didn't animate an actual arrow. If you want to, you can use U and D for up and down. I don't mind that as far as trying to figure this out. But when we find aluminum, I need to account for 13 electrons. And Aufbau's principle says we have to do 1s before we do 2s. It's like climbing a ladder. Before we do 2p, before we do 3s, and then 3p. And then it gets a little bit wonky over here. What? Very good, baby. I'm teaching. She divided. Woohoo! So Aufbau says we have to fill 1s first. It can hold 2 electrons. Okay, so now the first one we do as a clockwise or an up arrow. Okay, and we have, if there's more than one orbital, like in the P or the D or the F, then each one gets 1 before we double up. But Pauli exclusion principle says that we're bringing in the second one, which is the case of aluminum, that it must be opposite spin. So 1 is up and 1 is down. That's the only thing that the 1s can hold. And it's, if I have to keep toggling back and forth. Okay, so it is literally 1s up, 1s, 2 down, 1. And then we're going to move to the 2s shell. And then we're going to move to the 2p shell. And then we're going to move to the 3s shell. And then we're going to move to the 3p shell. You're literally reading this thing from left to right. So after 1s is 2s, we're going to do 1 up, 1 down. Once again, s shells can only hold 2 electrons total. Now here's where it gets a little tricky. Your p orbital has 6. Now each orbital has 1 up. So we had 1, 2, 3, 4, 5, 6, 7. Remember, I got to get to magic number 13. Then we're going to come back and do down. 8, 9, 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need 3 more. After that, we go to 3s. So we have 11 and 12. And then I need 1 more, which is 3p. And on the periodic table, to keep going back and forth between tabs. So aluminum is right here. I push it in a little bit. Is right below my finger, and it is in the 1, 2, 3rd shell down in the P block, and it is the first element over. And so when we are doing configuration, and this is a tie over from Friday. When we're doing configuration, this last bit actually tells you where your atom is. It's in the 3rd row down, the 3rd period within the P block, which is groups 3 through 8, and it's the first element over in that row. If you want to know what the element is, this right here, this very last bit, this is what is going to tell you where that element lies. I'm going to go back. I'm going to double check. It looks like I got more people that joined on. Okay, so I don't see Bailey. Brianna. I'm technically only supposed to be able to do remote, but I'm still checking to see if y'all are logging in. Aiden's not there. Eva, Braden. No. Jeremiah. Okay. All right, let me go back. All right, so now the next element, we have tin. When you find tin, which is SN, on the periodic table, it has an atomic number of 50. So the thing that's nice, if I give you electron configuration in this order, it's already set up for off-bow. So after 1s is 2s, and then is 2p, then 3s. I almost said 2p, then 3s, then 3p. Then we have to do 4s before we do 3d, and then 4p, then 5s, then 4d, then 5p. This is, I don't see notes. Here we go, notes 15. That is this, already set up in order for you. Now, what's confusing on the assignment from Friday is the person who made the slides inversed this. So 1s was on the bottom, but still after 1s, you're going to do 2s, and then you're going to do 2p. Oh, you guys can't see that particular screen. Let me go and share my screen. Just give it just a second. Okay, so if I go back to what I was just trying to show you, and I wasn't paying attention. Okay, there we go. So this is off-Bell's principle. This was from Friday. What made it a little difficult on your assignment was they flip-flopped this upside down. But you still will fill 1s, and then you will fill 2s, and then you will fill 2p, and then 3s. And I am talking about this assignment right here. Okay, so after 1s, you're going to do 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p. You're literally following this order, which is why I actually want you guys to put this on your colored periodic table. Go back to, okay, so 10, we're going to 50. We've got 1, 2, 3, 4, 5, 6, 7. I know my lines aren't perfectly straight. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 1, 2, 3, 4, 6, 7, 8. So now that should be 50. So if I show you, it's not going to work. And let's stop presenting and put it back on the right slide. Quantum mechanics share. Okay, so now if I show you my colored periodic table, and we were going to 10, 50? Yes. Okay, so 10 is right here on the periodic table, number 50. So we are down 1, 2, 3, 4, 5. I am in the P block, and I am the second element over. And so on my configuration, back to that slide, we're the 5th row down, we're in the P block, and we are the second element over. This is literally what tells you where we are. Now the S's and the P's, they go 1 through 7 down the left-hand side. Your D block shifts up a letter, and so does your F. But if you put this stuff on your colored periodic table the right way, you've got that shell number there for you already. And the next one we're going to do is radium. This is atomic number 88. I'm not going to do it with all those blanks. I am literally, and if you look at the one that has my face instead of the presentation, we're going to radium, which is down here in the 7th shell. It's in the S block, and it's the second one over. So I know full well that it's going to end with 7S2. So I've got 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, then I'm going to go down to my 4F14, then I'm going to go up to my 5D10, then I'm going to go over to my 6P6, and then 7S2. And if I'm echoing, I apologize, I just took that off. If you're following your periodic table from left to right, it tells you how to do this. And I'm going to flip-flop. I'm going to let you guys copy this down here in just a second. I'm going to wait for just a minute, make sure I don't have, okay, there's something in the chat. Okay. Luke, stop. Okay, I am going to switch the way I present to a different screen just to show you how I did this. This is so much easier to do in person. So I'm going to go back to here. All right, so radium is right here. That's where it belongs. So it's configured. I can't stop until I get here. It is literally 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2. Now these belong in this hole. 6S2, 4F14, 5D10, 6P6, 7S2, and I'm finished. So stop presenting. Present now. All the mechanics. Okay. Sorry, this flip-flop takes a little bit. Now, that's an awful lot of numbers. It's a heck of a lot to write down. So we've developed a shorthand. And what we do is we go up one level, up one period, to the noble gas, which is all the way on the right-hand side. And we use brackets, and we put that symbol in there. It's okay, kitty cat. And then we put all of the SPDF stuff after that we need to get to the element. So in the case of radium, its most so radium is Radium is here. Okay? Its most recent gas is in the 6th shell because radium is in the 7th shell, and it's actually radon. So we would put radon in brackets, which is Rn, and then we would do 7s2, and we're done. So there is a shorter way to do this, but you've got to use those elements on the right-hand side, which are called noble gases. You put the most recent one, which just means up a level, up a period. You put that in brackets, and then anything else after. So strontium. If you find strontium on the periodic table, its atomic number is 38. You go up one shell. Strontium is, let's see, let me find him, 38, is in row 5, period 5. So we're going to use period 4's noble gas, which is krypton, which is Kr. We're going to put it in brackets. So that counts for all 36 electrons through krypton. And then we're just going to put the 5th energy level, the fact it has 2 electrons in it. And it shortens it down quite a bit. So we ignore the 1s2, the 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. We ignore that because krypton means that. So we put that in brackets, and then we just have everything left over, which is the 5th shell, which includes rubidium and strontium. So it is 2 elements over in the S cloud. Oops. My attendance is logged out due to inactivity. Another example, iodine. Iodine is number 53 on the periodic table. So its most recent gas is still krypton. So we're going to put krypton in brackets. And then I have to count everything going over to iodine. So it'll be 5s2, 4d10, and then 5p, and iodine is the 5th one over. So this means the 5th, the p block, the 5th element over, which happens to be iodine, which is number 53. Tantalum, number 73. That is a transition metal. It's in the 6th block. So I'm going to use the 5th period's noble gas, which is xenon, and I'm going to put Xe in not parentheses, brackets. And then I'm going to include 6s2, and then 5d, and tantalum is the 3rd one over. Oh, I forgot about the Fs, 4f14. The transition metals belong in between barium and lutetium. That's the 4th shell. And then the 5th shell belongs between radium and lawrencium, which is the 5th shell. And like I said, if you did this thing the right way, you have the numbers 4 and 5 next to your inner transitions, and your 3, 4, 5, 6 next to your transitions, but your S's and your P's are 1 through 7 straight down that left-hand side. What element corresponds to the following positions on the periodic table? Okay, if you've got your color periodic table, 3D5, we're going to go down 3 rows, but we're going to be in the D block, which is in the middle part that has the orange cross lines, this part right here. So the 3rd in the D block, and we're going over 5, 1, 2, 3, 4, 5, which is manganese, which is the symbol Mn, number 25. 4p3, we will go down 4 blocks, 4 rows, we're in the P with the 3rd one over, which is arsenic. And if I change the way that I'm presenting, okay, so that first one, if I go back, I'm gonna look and see. So that first one was 3D5. So 3D, 1, 2, 3, 4, 5, that's manganese. The next one was 4p3, if I'm not mistaken. 1, 2, 3, this one is arsenic. 5f10, we'll go down to the 5th in the F, which is the very, very bottom part of the periodic table, like the part that's pulled out. And now we're going to go across 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That is californium. And then 2s1, we go down to the second one, first one over. That one is lithium. And like I said, this thing, once you learn how to read it, is your cheat sheet for the rest of the year. Okay, now I'm going to change the way that I'm presenting. Actually, no, I'm not. Okay, so if I go back into Canvas, and I know that your screen looks a little different than my screen. If you do not do, I can't speak grammatically. If you did not do the quiz, I reopened this quiz from Friday because so many of you did not do it. You're simply matching the symbols with the elements. I made sure that this electron configuration thing is open because I know that we're having problems with it. I'm sorry, the assignment that goes with it. And then I forgot to make those notes hot. So they're hot and they're answered. Now, keep in mind, your notes are due as a test grade this 6 weeks. So what I did was I gave you the list of your notes in order. Okay, and they're going to be through the notes that we're going to do tomorrow. So we're right here at electron configuration. These are the order that I gave them to you. Okay, they may not be in that order in your drive. If you forgot how to submit, now you're going to have to upload your paper notes. I know a lot of my students do paper notes. You've got to upload your notes, either scan them at home or possibly take a picture with your phone and get them into Canvas. But I posted second 6 weeks notebook submission. You guys have through Thursday to do this. What I did, this YouTube link, it was from my Earthspace from last 6 weeks, but it explains to you how to do this step by step by step. So in your drive, if you've not done this, what you need to do is create a chemistry folder, especially those of you that have been doing paper. Within your chem folder, there should be a first and a second 6 weeks tab. In your second 6 weeks is where you're going to drag your notes. Now I use a mouse. I don't right click. And all of these look like they're copies. Let's look and see. Yeah, I haven't organized my chemistry drive. So if we have issues, I can help you with this on Wednesday for you guys. But you're going to drag your stuff into your chem folder, and then you're going to drag from your chem folder into the right 6 weeks. You're not ready to submit it yet because we still have notes tomorrow. When it does come time, in order to share this, once you go into the right folder, this is how you do it. You get a link, but this is what people forget. You need to switch it off of restricted to ASL. Y'all don't have this one, but you switch it off of restricted to ASL, then you copy your link. Then you can go back into Canvas and you can submit that because you have a submit button that I don't have up here. I know that it's a lot with the assignment that was from Friday. So this guy is still open. A lot of this is just drag and drop. There is a separate assignment today, but I've extended everything's date, if I'm not mistaken, through Thursday, just to make sure you have enough time to take care of everything. This one just wants to know if just the P level, the third P level is filled, how many electrons would that be? The entire second energy level, so both the S and the P, how many would that have? Any orbital in general. Each orbital, I don't want to just tell you the answer, but they can only hold a certain amount. They can't go past that. Otherwise, they have to jump to the next orbital. Not level, orbital. Those are those blanks like these. This is an orbital. This is an orbital. This is an orbital. This is an electron shell. This is the p shell. This is the d shell. It has 1, 2, 3, 4, 5 orbitals in it. This one wants you to put them in order from lowest to highest energy. This one wants to know your element. We just did this. Go to the 5th row down into the S cloud, the first element over. Second one down, P cloud, 4th element over. Into the 4th F cloud, the 4th element over. You're literally pulling those off of the periodic table. Same thing for these. Same thing for these. Don't worry about that. Third one down in the D shell, 7th element over. Same thing. Don't worry about those. So many far down. This case, it's a 5th one in the D shell, the 10th element over. It's just a matching. Now, when I showed you guys how to do this on here, it's just upside down. It's just reversed. It's still in the same order. You still do 1S, then 2S, then 2P, then 3S. But, and I know this is confusing to some of my students in 8th period, you're still filling first S, then second S, then second P, then third S, then third P, then 4S, then 3D, then 4P. You're following Aufbau's principle, which is in your notes. And once again, that is this. This is the order. This is the order that they're being filled. And so if you did not understand the one that we were doing Friday, hopefully this makes a little bit more sense. But you do have until Thursday to fill this particular assignment out. Let me stop recording. I am about to post